in this next section, what we're going to look at is absolute value inequalities. So the idea is going to be the same as what we were doing before. The goal is going to be for it to look like the following. The goal is for us to get the absolute value by itself. Our inequality would be next. Once the absolute value is by itself, we'd have our number on the other side. Just like before, it should be a positive value or the smallest 0. And then you'll do what we did before, which is break it up into its two versions. We'll do a positive version and a negative version. Notice what's inside of the absolute value will stay the same. We'll just have one inequality where it's your positive version and an inequality is pointing at the same direction. Nothing will really change. However, with the negative version, our inequality is going to point in the opposite direction. So we're still going to have two parts to our inequality. We're just going to break it up into two pieces. So let's take a look at problem A. In problem A, we have, the absolute value of x minus 5 is less than or equal to 2. So what's nice is the absolute value is already by itself on the left-hand side, and your positive number 2 is on the other side. So we are perfectly set up. So what we're going to do is we're going to jump to, once you have your absolute value by itself, doing our positive version and our negative version. Our positive version, just like before, whatever is inside of the absolute value, the x minus 5 will stay the same, and we'll leave our 2 as a positive 2. And in the positive version, our inequality will stay the same. So it looks almost identical. It's just we're dropping the absolute value signs. And that will always be the case for our quote-unquote positive version of our inequality. Next, let's look at our negative version of our inequality, which, again, just like before, whatever's inside the absolute value on the left will stay the same. So it's got to have the x minus 5. And it's a negative version, so instead of a 2, we'll have a negative 2. Now, what is usually the catch when we have inequalities and we start throwing around negatives is the inequality switches direction. Same thing here. For our negative version, we're going to switch the direction the inequality is pointing. So, when we've got our positive version, everything stays the same. When we've got our negative version, we're doing two things. We're switching the sign, and we are also flipping the inequality. So we're doing two things here. So we need to be a little bit careful. So we'll start by looking at the first inequality, which we'll start by adding 5 to both sides of the inequality, which will give us, x is now less than or equal to 7. And on the other one, we'll do kind of something similar. We'll add 5 to both sides to solve that inequality, which will give us, x is now greater than or equal to a positive 3. So let's go ahead and take a look at our number line. We should have two values on our number line. Let's put the first one first, which is the number 3 is the smallest. And the number 7 is the largest. So one thing at a time, let's start with the first answer we got, which is that x is less than or equal to 7. Well, because the x comes first, the direction the inequality is pointing and the graph will be the same. So from 7, we should be pointing to the left. And because of the equal to, it should be a bracket. Now, on the second part, we have the same idea. From 3, we're pointing to the right. Because the x is going first, our graph will do the same thing, point to the right. Now, it does have an equal to, just like the 7, so it's going to be a bracket as well. So if we were to read this interval notation, or this interval graph from left to right, we could come up with the interval notation that the graph starts here at 3 and ends at 7. So we'd have 3, we'd have 3 to 7 with, a comma in the middle. And notice the 3 does have a bracket and the 7 does have a bracket because of the equal to's, and that would be your final answer. Do keep in mind that you cannot write your final answer with just the inequalities. They always expect your final answers to be in interval notation. Next, let's take a look at B. In B, we have, let's see, the absolute value of 5x plus 2 minus 2 is less than 3. So the first thing that we'd notice is that the absolute value here on the left-hand side is not by itself. We've got this minus 2 that's dangling off next to it. So we need to move that or get rid of that minus 2 by adding 2 to both sides of the inequality. And let's see what that gets us. Now we have the absolute value of 5x plus 2 is now less than 5. Now that does help us because now at least everything is on, everything with the absolute value is by itself, and everything that's a number is positive and on the other side. So once we have this set up where we've got our absolute value by itself and the positive number on the other side, we can break this up into our two pieces, our positive version and our negative version. So let's see. The positive version, which is when everything's going to stay the same, is we'll leave the 5x plus 2 inside of the absolute value the same. The positive value will stay the same, and the inequality stays the same. The negative version is always going to be the trickiest. We still keep what's inside of our absolute value the same, the 5x plus 2. However, the 5 on the other side does. We're looking at the negative version. Actually look at, so we'll look at a negative 5. And whenever we start throwing negatives with inequalities, remember we normally switch the sign of inequalities, which way it's pointing. So that's what we'll do here. So remember we do a switch the sign, and we flip the direction. The inequality is pointing. Okay, we still have to solve both of these though. So let's start with the first one. We'll subtract 2 from both sides, which will, let's see, give us 5x is less than 3. Next thing that we'll do is we'll divide both sides by 5, which will get us that x is less than 3/5. Perfect. Now we need to do the same thing with the second version. We'll subtract 2 from both sides, which will give us, let's see, 5x is greater than negative 7. Then we'll divide both sides by 5, which will give me that x is now greater than negative 7/5. So we've got two parts, and we've just got to put this together now. First thing that we've got is our first value is the smallest value is negative 7/5, and I'm just going to throw that on my graph. The second value that we have is positive 3/5. Let's start out with one at a time. Let's start out with the negative 7/5 first. Notice that that inequality, because the x comes first, is pointing to the right, will point the same direction when we draw its graph. Notice that there's no equal to this time, so we're going to use a parentheses, not a bracket. However, let's take a look at the other inequality. We get x is less than 3/5. So again, it'll be pointing to the left, just like our inequality. Again, you can only use that trick when the x comes first. There's no equal to, so we'll use a parentheses again. So that's what our graph is going to look like. Now let's read it from left to right to come up with the interval notation. From left to right, the graph starts at a negative 7/5, where we have a parentheses, comma, then it continues, notice, until we get to positive 3/5, where we have another parentheses. And then continues along, and there's no other graph after that. So we're done. This is our final answer, is we have a parentheses at negative 5, comma, 3/5 with another parentheses. In this next